So here in this problem, we need to show that the line joining the midpoints of the opposite sides of a quadrilateral and the join of the midpoints of its diagonal meets at a point and they're going to bisect each other. We need to understand this problem graphically first. So let us begin. So here we have the Cartesian plane with the x and the y axis, and we're considering a quadrilateral. Let's name the quadrilateral as OABC. And we are also going to consider its vertices. So since O is at the origin, so its coordinates are going to be 0, 0. Let's suppose that the coordinates of A that's given by x1, y1. B is lying on the x-axis, so its coordinates are going to be x2, 0. And then we have the coordinates of C. Let's call it x3, y3. Now, OB is the diagonal of the quadrilateral. Fine. We'll consider the midpoints of OC and the midpoints of AB. Suppose the midpoints of AB is at E and the midpoints of OC is at F. Fine. So we're going to join E and F. OB is the diagonal, but we'll also join O and C to get the other diagonal of the quadrilateral. Now what we'll do, we'll consider the midpoints of the two diagonal. That's it. The midpoints of the diagonal OB of the quadrilateral is at, let's call it P. And the midpoints of the diagonal AC, let it be at Q. Right. If we join P and Q, it's going to pass through the midpoints of EF. That means that is what we need to show. We need to show that PQ passes through a point, let's call it the point R, in such a way that R is the midpoint of EF. That is what we need to show. Right. So let's begin our problem. We'll begin by first computing the coordinates of E and coordinates of F. Now clearly E is the midpoint of AB, which means that we can easily find out the coordinates of E. To do that, all we have to do is, for the x coordinate, let's begin with the x coordinate, we'll take the sum of the endpoints of the x coordinate. Now the endpoints of E are going to be A and B, so that's going to be x1 plus x2 divided by 2. And to find out the y coordinates, we'll sum up the y coordinates of A and B and divide by 2. And that means it will be simply y1 over 2. So that's going to be the coordinates of point E. Similarly, F is the coordinate of OC, so we can also define the coordinates of point F. The coordinates of F are going to be, so we will take the sum of the x coordinates and divide it by 2, and take the sum of the y coordinates and divide by 2. So now that we have the coordinates of point E as well as coordinates of point F, we can also find out the midpoint of EF. So here we will consider that R is the midpoint of EF. So let's find out the midpoint of EF. So the coordinates of R are going to be, so we'll take, for the x coordinate, we'll take the sum of the coordinates of E and F and divide it by 2. So we already have the coordinates of E and the coordinates of F. The sum of the x coordinate is going to be x1 plus x2 plus x3 divided by 4. And for the y coordinate, we take the sum of the y coordinates of its endpoints, which is y1 over 2 added to y3 over 2 and divided by 2, and that's going to give us y1 plus y3 divided by 4. So now we have the coordinates of R, so we're going to keep it aside as number 1. Fine. Now what we'll do, we'll find out the midpoint of the diagonal AC. Now what's the midpoint of the diagonal AC? We've already considered Q to be the midpoint of diagonal AC. Since Q is the midpoint of diagonal AC, so we can now also find out the coordinates of coordinates of Q. That's very simple because we know the endpoints A and C. We've already defined it. So coordinates of Q will be, take the sum of the x coordinates, so that's x1 plus x3 divided by 2, and the y coordinates is going to be y1 plus y3 divided by 2. Now what we'll do, we'll find out the midpoint of OB, the diagonal OB, which is going to be P. So P is the midpoint of diagonal OB. So coordinates of P is going to be, so we'll take the sum of the x coordinate, so that's x2 divided by 2, and the sum of the y coordinate, so that's going to be 0 divided by 2. Fine. So now that we have the coordinates of P as well as coordinate of Q, what we'll do, we'll try to find out the coordinates of the midpoint of P and Q. So that for that, we simply, so let's name this. We haven't named this yet. So we're going to call it S. So we'll try to find out the midpoint of S. That's the midpoint of the line PQ. So S system is point of Q. Coordinates of point S is going to be, so we'll have to take the sum of the x coordinates of P and Q. So the sum of the x coordinates of P and Q is going to give us x1 plus x2 plus x3 divided by 2. And the sum of the y coordinate, that's going to be y1 plus y3 divided by 2. However, I made a mistake here. So there is no y2 term here. So this is an extra term that I've added. Actually, it is y1 plus y3 over 4. Which is evident here. So that's the y coordinate of E is y1 over 2 and the y coordinate of F is y3 over 2. So our sum should be y1 plus y3 over 4. The coordinates of R, we're going to label it as number 2. Now from 1 and 2 we observe that they have exactly the same value. So that means the point R and actually the point S are not two different points, but they are the same point. So that means R and S coincide. If they're coinciding, so that definitely means that PQ is bisecting EF. So we have successfully showed that PQ bisects the EF, hence proved.